purpose of this unit is basically to be able to say we're proving that this figure is not only a quadrilateral, but it's also this type of figure, whether it's a square or rectangle or whatever. Okay? You can't just look at it and go, well, it looks like that. You have to be able to prove it. Okay? So there's a flow chart of what you have to do. All right? So what's it mean to be able to say it's a quadrilateral?
4 sides.
4 sides. There we go. So we look at the figure and say, hey, does it have 4 sides? Yes, it does. Boom. It's at least a quadrilateral then. Okay? The next thing to compare is if it has 1 set of parallel lines or 2 sets of parallel lines. All right? So how do you tell if parallel lines are parallel? Or lines are parallel, I guess I should say. What do you compare?
They have the same slope.
They have the same slope. Okay? So you have to look at the same slope. Okay? Now, we have 2 different ways to look at that. If we have a graph, then how can we tell the slope of the line? What do you mean that?
Like the same. Get 2 points and then find that have the same length.
If you have the equation of the line, that would work. But if I'm just looking at a graph.
Yeah.
No. How do you find this? We already got that. Well, what we're doing, we already decided that to see if they're parallel, they have to have the same slope. When you're looking at a graph, how do you tell if 2 lines have the same slope?
If they both go up the same.
The rise and the run. They both go up the same, the rise and run. So you look at the change in y over the change in x, which is the same thing as your rise over run. Okay? Okay. If you just have ordered pairs and you don't have a graph, how do you find the slope? Thanks for raising your hand.
X2 minus x1 or x1 minus x2. Oh, no, it's y on top.
Yep, y on top, perfect. So y2 minus y1 over x2 minus x1. Either way works. Either method works. It's all good. Okay? All right. If you only have 1 set of parallel lines, what kind of figure do you have? You have a trapezoid. That's it. Okay? You can tell if it's an isosceles if the sides are the same, but there's nothing isosceles sides, same length. But there's nothing else really basically to do. Okay? If you have 2 sets of parallel lines, then it's a parallelogram. However, parallelograms have a lot more things they could be. They could be the rectangle, they could be a rhombus, and they could be a square. So now we got to look at those to see if it's a rectangle, rhombus, whatever. Okay? So, first question. You want to do a rectangle or a rhombus? First.
Rectangle.
Rectangle? Okay. So, let's see if it's a rectangle. And so, we have 2 properties that we can look at. One property of a rectangle is that diagonals are congruent. How can we prove that my diagonals are congruent? So I have this shape here, and I got 2 rectangles. How can I prove that this side is the same as that side? How do you tell if they're the same length? Can't measure anything. We're proving it. How do you tell if something is the same length? formula we did in last unit. That was reason why we did it last unit. What'd you say? No. Pythagorean theorem does... Actually, you know what? That's not true. I lied. You definitely could do that way. If you knew this side length and this side length, you absolutely could do Pythagorean theorem. But chances you're not going to know. It will take more work. There's one other. What other formula?
If both opposites.
No, the diagonals have to be congruent.
Yeah, but like, wouldn't you know both of the all four sides would be distant?
But you have to prove it. Yes, Ethan, that's what I'm looking for. Yep.
Yes. So if the four sides.
Ladies and gentlemen, stop the chatter.
The two top sides would be sides. Left and right is opposite.
Yeah, but you have to prove it, and you can't just by looking at it go, "Oh, I think they are," because it might be a shape that's so where it's not just so nice and neat kind of thing where it looks like it. But Ethan hit it. What'd you say? Use your distance formula to actually find the distance of it. So, I remember the distance formula.
It's like x minus x1 squared
Yep.
plus y equals to minus y squared.
Perfect. Okay. So you can use the distance formula to find the length of the two diagonals. If both diagonals have the same length, then they're congruent, and then it's a rectangle. Okay? If they're equiangular, what does that mean? What's equal? The angles are equal. Okay? And what is the sum of all angles in a quadrilateral? 360. And if they're all equal, we could divide it by 4, which is going to give us our 90 degree, right? Now, how do we prove two lines create a 90 degree angle? They're not supplementary, we're complementary. They become, say what? No. Hold on a minute. I want to wait till we get everybody's attention because I'm having a hard time staying focused with the side conversations. Okay. So, how do you tell if two lines form a right angle? Not the length. It's about the intersection. They're perpendicular lines. Okay, and how do you tell if they're perpendicular lines? How do you tell if they're perpendicular lines? Last unit.
Slopes.
Opposite. Almost. There's one more word. Slopes are opposite.
Exterior.
Reciprocal.
Yeah, that's what I meant. Yeah, dang, I messed up. Dang, I got it in my head.
Okay, perfect. Okay, so that means that if I had a slope of like -1/2, my opposite reciprocal, if I'm negative, then what's the opposite sign? Would be positive. Reciprocal means to flip, so it would be 2. Perfect. Okay? To prove a rectangle is a rectangle, you only have to do one of these. Okay? If you love using the distance formula, find the length of diagonals. If you love doing slope and think it's easier, do to see if it's angulars, okay? Especially because if you have one that's 90 degrees, then the other one should also be 90. You gotta check them, but it should.
So, can we use any of them on anyone, or like for some we're gonna have to use a certain one?
No, it's your choice.
So, no matter how what the rulers like to use this.
Okay, so if it was a parallelogram, you have two choices. We just talked about how to prove whether it's a rectangle. And the other choice would be if it's a rhombus. Okay? So, we're going to look at, are we a rhombus? The property of the rhombus is that diagonals bisect an opposite angle. Do we have a method, you know, like the distance formula or perpendicular lines or anything like that, that are going to tell us that diagonals bisect an angle? Only unless they give you that information, okay? Okay, so that one tends to not be a really useful one. However, equilateral. What's equilateral mean?
Its sides equal.
Sides are equal. Okay, so how could I tell if my four sides are equal? How did I find if my diagonals were equal? Distance formula. Okay, this one's a little bit putzier because you got to do it for all four. But hopefully they're not, oh, what's the word? You know, that they're kind of easy ones. Okay, then our last choice are that diagonals are perpendicular. Okay, so I got this figure. I can draw diagonals anytime I want. How am I going to tell if the diagonals are perpendicular? By what? What same way? How do I tell if anything's perpendicular? What am I going to look at?
The right angle, like the right angle.
What am I going to do?
Opposite.
Look at your slopes.
Yeah.
Okay, so compare the slopes, and they have to be opposite reciprocals.
All the way on graphic or
No, sometimes it's just an ordered pair. You know, if you have four, I don't agree with that. If you have four, like on our thing the other day, we just had our vertices. Okay, so kind of depends. All right, now, I went from the parallelogram, and then I did a rectangle and rhombus, and I could be in like, you know what, no, I'm not a rhombus, no, I'm not a rectangle. Then what happens? Well, hey, I'm just a parallelogram. But if I get through and say, okay, I know I'm at least a rhombus, now I have to check to see, well, am I a square? And in order to be a square, I have to go back up and prove one thing of the rectangle. Because the square has to have the properties of the parallelogram. Well, we already did that when we checked to see if there's two sets of parallel lines. We wouldn't have gotten that far.
So, if it turns out being a rhombus and then a square?
If it turns out to be a rhombus, then you need to check for one property of a rectangle.
So, if we found like, it was equal, angular,
Uh-huh.
and
So let's say I proved the rectangle, it was a rectangle, okay? So I've proven it's parallelogram, I've proven it a rectangle, now I got to prove it's a rhombus. So now I got to go back and look and see if the diagonals are perpendicular or if it's equilateral. Okay? Does that make sense? All right, we're going to do one of these together. So get that sorting activity packet that we had last week back out.
I go to the restroom.
Yes.
Did you print me a copy this time?
No. You have the cards, right? You just need to sort. It's on my list, and then we had ice and all sorts of stuff. Ask me what? You're done. All right, here we go. Now, on these, I numbered them. Okay, so for our example, we're going to do number 6. I can find it. Okay, so number 6 tells me I have vertices at 3, 5, 3, 1, -1, 2, and -1, -2. Now I'm going to write those down so I can keep track. No, but I'm going to make a copy. I'll be more than happy to make one for you. Okay, we're doing number 6. Okay, now the first step I'm going to want to do is I need to plot my points. Take a look at the graph. What do you notice about the graph? What do you notice about the graph? Look at the origin. Starts at 1. Isn't this weird? I downloaded these off the internet. So we're going to make this origin. That means I need to renumber. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think it's just the way it typeset it. Because it said it was a 5-grid graph. So I think it just was, because the negatives are fine. It's just the positives. Okay? All right, so let's plot my points. 1, 2, 3, 1, 2, 3, 4, 5. I'm going to call that one A. And then I have 3, 1. We'll call that one B. Then I have -1 and 2. We'll call that one C. And -1, -2. We'll call that one D. All right, so I'm going to draw my lines. All right, here we go, prove it. First step. Do I have 4 sides?
Yes.
So what am I at least?
Parallelogram.
No.
Quadrilateral.
Quadrilateral. Okay. Now I'm going to check to see if I am a parallelogram. Parallel. Keep spelling it wrong. Oh, gram. Okay. Do I have at least one side of parallel lines? Which ones? Oops, I forgot to do. Somebody said the what? How do you know AB and CD? AB is parallel to CD. How do we know that? Just by looking at
They're
them.
the same length.
It's not that they're the same length. That's not has to do with parallel. Parallel slope.
They're straight along to.
They are
Parallel.
straight along the lines. Okay, so that what kind of slope is that called when they're up and down? They're vertical lines, but what are the slope? Undefined. Perfect. Okay. All right, so at the bare minimum, if I have one set of parallel lines, that means I have to have a trapezoid. Okay? So the second step is, do I have two sets of parallel lines? How do I find the slope of AC?
Rise and run.
You can do rise over run, or you can do the slope formula, whichever one you want to do. I'm going to say that the slope of AC is going to be up to 3, and then over 1, 2, 3, 4. And the slope of BD is going to be up to 3 and over 2, 3, 4. Since I have the same slope, that means that BD is parallel to AC. Which means I'm at least a parallelogram. Okay, so do I want to see if it's a rectangle or a rhombus? I hear a rectangle and a rhombus. Now, let's stop and think about something for a minute. For it to be a rectangle, I have to have 4 right angles, correct? I have a line that has an undefined slope. Put your phones away, please. What is the slope that of the line that has to intersect with that in order for it to be perpendicular? If I have an undefined one going like this, what kind of slope has to create my perpendicular line? A 0. Is this line 0? No. So therefore, it can't be a rectangle. All right? So I just eliminated, it's not going to be a rectangle. If it's not a rectangle, it's not going to be a square. So now, now I have to prove it's a rhombus.
But we know it's a rhombus.
We don't know it's a rhombus because you haven't proved it's a rhombus. It might look like it, but it doesn't prove it. So, well, we know it's at least a parallelogram. All right, so do you want to see if the diagonals are perpendicular or if the sides are equal? So basically, you want to do slope or you want to do the distance formula? Distance formula? Okay. So let's find the distance for AB is going to be easy because it's a straight line. So I can just count it. 1, 2, 3. All right. And the distance of CD is going to be easy because it's just 1, 2, 3. Perfect. But now I need to find the distance of AC, right? So I'm going to have the square root of 3 plus 1 squared plus 5 minus 2 squared, which is going to give me 4 squared plus 3 squared, which is going to give me 16 plus 9. So the distance of AC is 5. Okay? Now, do I need to prove the distance of BD at this point? It's not a rhombus. So, it's not a rhombus. It's not a rectangle. Yeah.
Okay, I'm confused because you put for AB, you said 3, isn't it 0?
1, 2, 3.
Wait. What do you count
Oh, oops, sorry. But 4 and 5 still are going to be different. But yes, you're correct. I'm sorry, I counted wrong. Okay, so therefore, we proved it's not a rectangle. We proved it's not a rhombus, which means it is just a classification of a parallelogram. Okay? Make sense?